Red oval cloud feature located at 55 degrees south latitude is shown in this false color image of Saturn's southern hemisphere. The photograph was taken by the spacecraft at a distance of about 5 1/3 million miles. The difference in color between the red oval and the surrounding bluish clouds indicates that material within the oval contains a substance that absorbs more blue and violet light than the bluish clouds. Two brown ovals at the right of your screen, some 6,000 miles across, were found at approximately 40 degrees and 60 degrees latitude in Saturn's northern hemisphere. The photo was taken from a range of 4,600,000 miles. The polar oval, upper right, has a structure similar to the Saturn red spot located in the southern polar latitudes. Saturn is the second largest planet in our solar system. It has a volume 815 times that of Earth, but a mass only 95.2 times greater. Like its giant neighbor Jupiter, Saturn's extremely rapid rotation has caused the planet to be flattened at its pole. The clouds covering Saturn's satellite Titan are seen in their true colors in this image taken by Voyager at a distance of 2.8 million miles. Titan's southern hemisphere appears as the lighter region with a well-defined boundary between the clouds around the satellite's equator. Titan's surface is believed to be shrouded by aerosols rather than the convected clouds found in the atmospheres of Jupiter and Saturn. Titan is one of the largest satellites in the solar system. Its size approximates the planet Mercury, and it is the only satellite to have retained a substantial atmosphere. Saturn and its satellites Tethys, outer left, Enceladus, inner left, and Mimas, to the right of the rings, are seen in this mosaic of images taken by Voyager 1 from a distance of 11 million miles. Features larger than 220 miles are visible. The projected width of the rings at the center of the disk is 6,000 miles. Saturn was thought to be the only planet encircled by rings until the discovery of Uranus rings in 1977 and Jupiter's in 1979. The heavily cratered surface of Tethys was photographed from a distance of 750,000 miles by Voyager 1. This face of Tethys looks toward Saturn and shows a large valley about 500 miles long and 40 miles wide. The craters are probably the result of impacts, and the valley appears to be a large fracture of unknown origin. The diameter of Tethys is about 600 miles, or slightly less than 1/3 the size of our moon. A color portrait of Saturn's moon Rhea was reconstructed from 3 Voyager 1 images. Range from the spacecraft to the moon was about 1 million miles, giving a resolution of about 20 miles on Rhea's surface. The color has been exaggerated somewhat to bring out subtle color differences between the brighter streaks and darker background. The photo shows many wispy light markings on Rhea's surface, which are neither identical to simple ray crater markings nor the grooved terrain on Ganymede in the Jovian system. Here we see a view of Saturn's clouds extending from 40 degrees to 60 degrees north latitude. Visible is a ribbon-like wave structure in the south with small convective features marking a westward jet in the north. Like the 3 other gas giants, Jupiter, Neptune, and Uranus, Saturn has no solid surface, but is a huge multi-layered globe of gas with a small core of iron and rocky material. Saturn's F, or outermost ring, was photographed from the unilluminated face of the rings by Voyager 1 at a range of 470,000 miles. 2 narrow, braided bright rings that trace distinct orbits are evident. Visible also is a broader, very diffuse component about 20 miles in width. Note the knots, which probably are local clumps of ring material, but may be mini-moons. This enhanced Voyager 1 image was taken when the spacecraft was 2 million miles from the planet. The smallest features seen are 36 miles. Enhancement has brought out contrast of features in the north polar region of Saturn. The chevron-type pattern of white features in this upper portion of the image reflects the local cloud motion. Many large impact craters are seen in this view of the satellite Dione, taken by Voyager 1 from a distance of 149,000 miles. Bright, radiating patterns probably represent debris rays thrown out of impact craters. Other bright areas may be topographic ridges and valleys. Also visible are irregular valleys that represent old fault troughs degraded by impacts. Multiple impact craters are seen on the ancient surface of Rhea in this picture taken by Voyager 1 at a range of 45,000 miles. The craters closely resemble those on Mercury and the Earth's moon. Many of the craters have central peaks formed by rebound of the floor during the explosive formation of the crater. These Voyager 1 images of Saturn's 11th moon, a trailing co-orbital satellite, were taken from a range of 110,000 miles and show the south polar region of the body. The pockmarked moon is approximately 83 by 43 miles. Comparison of the two images, taken 13 minutes apart, reveal a narrow shadow moving across its face. This is probably cast by a small narrow ring of Saturn a few thousand kilometers away from the satellite. A large circular feature about 120 miles across with a dark spot in its center is visible in this photograph of the satellite Iapetus. The moon's leading hemisphere is to the left, and the trailing hemisphere, 4 to 5 times brighter, is to the right. The large circular feature is probably a large impact structure outlined by dark material, possibly thrown out by the impact. Titan's thick haze layer is shown in this Voyager 1 image taken from 270,000 miles away. Voyager images of Saturn's largest moon show Titan completely enveloped by haze that merges with a darker hood or cloud layer over the North Pole. The spacecraft's instruments found that the moon has a substantial atmosphere, far denser than that of Mars and possibly denser than Earth's. 8 hours after its closest approach to Saturn on November 12, 1980, Voyager 1 took this picture of the planet's ring system. Major features of the rings are clearly seen. The photo was taken from an angle of approximately 30 degrees above the ring plane. The unique lighting in this view brings out many hundreds of light and dark ringlets that make up this very thin, phonograph record-like ring system. Many impact craters, the result of the collision of cosmic debris, are shown in this Voyager